A function describes a relationship between one or more inputs and one output, which is the characteristics of the function. Two characteristics of the functions that you should become familiar with is the domain and the range, which we will go over in the second problem.
Okay, we're going to be learning about how to state the end behavior. So, the end behavior of a polynomial function is the behavior of the graph of f of x as x approaches positive infinity or negative infinity. The degree and the leading coefficient of a polynomial function determine the end behavior of the graph. So, some things you should know. Your key points you're going to be looking for are the leading coefficient and the degree. So, the first thing we're going to try to figure out in a problem is what our degree and our leading coefficient is. In this equation here, our leading coefficient is going to be 3, and our highest degree is going to be x to the third power. So whenever to find your leading coefficient, you first need to find your highest degree, and then you need to look at your leading coefficient. Some things about the leading coefficient is that whether it's positive or negative, that's going to determine which way the graph goes. So in this case, once you figure that out, you can find out how the graph's going to look. In this case, it's going to look just like this. Once you get that, you're going to plug it into your calculator, and then you're going to come over here, and you should graph to look like that. Once you have it plugged into your calculator, you can come over here to your equation, and you can plug it in. So as x goes positive, you see that f of x goes positive as well. Where when x goes negative, you see that f of x goes negative right here. That's your problem.
Okay, now we're going to be going over domain and range. Your domain is going to go from left to right, and your range is going to be going from bottom to top. So in this equation, y equals 3x minus 5 plus 2, we want to look at the key point of this function, which is the asymptote. When we have the leading coefficient raised to something such as x minus 5, it creates an asymptote at the number that follows, which is 2. Therefore, there's going to be a horizontal asymptote at y equals 2 until the equation reaches x equals 5. Therefore, our domain is going to be all reals as we're going from left to right, and then our range is going to be going from 2 to positive infinity as the asymptote is at 2, and from 2 we go all the way up to positive infinity.
Now we are going to talk about increasing and decreasing intervals. This is a pretty easy concept. Increasing intervals are the two x values in which the graph is going up, and the decreasing intervals are the at 2x values in which the graph is going down. The increasing intervals are negative infinity to negative 2.5 and 0 to positive infinity. Decreasing intervals are negative 2.5 to 0.